Going to solve this system of three equations and three variables. Three equations and three variables, those represent three planes. We're going to find the point or points of intersection of those three planes. The first step is to choose two equations and eliminate one of the variables. It does not matter which two equations you choose, and it doesn't matter which variable you eliminate. So I'm going to go with the first and second equations. First and second equations, I'm going to multiply the second equation by 2. That will end up eliminating the y when I add those two equations together. So top equation there stays the same. Bottom equation, if you multiply by 2, make sure you multiply each term by 2, including that 2 after the equal sign. So multiply each term by 2, get 4x minus 2y plus 2z equals 4. Then if you add those together, the y's cancel. That's what you want to have happen. You want one of the variables to be eliminated. So you have 5x plus 7z equals 3. The y's are eliminated. Circle that, mark it somehow, because most likely you're going to use that in a little bit. Next step, choose a different pair of equations and eliminate the same variables we eliminated the first time. So we're going to choose a different pair of equations and eliminate the y again. So this time I'm going to go with the second and third equations, and again we need to eliminate the y, so I'm going to multiply that first equation there by 4. So multiply that equation by 4, make sure you multiply each term by 4. You have 8x minus 4y plus 4z equals 8. Bottom equation there stays the same. Then if you add those together, the y's will be eliminated. So 8x and 3x is 11x, and not only are the y's eliminated here, but the z's are also eliminated. So we have two variables that get eliminated. That's a good thing, because the quicker you get to solving for one of the variables, the better. The faster you get done. 11x equals 22. Divide each side by 11. End up with x equals 2. So knowing that x equals 2, that's a key that's going to unlock the door to solving for all the other variables. So now that you know x is 2, this equation right here, you can use this to solve for z. So substitute 2 in for x into that equation. Take that equation, 5x plus 7z equals 3. Substitute 2 in for x, and then you can solve for z. So 5 times 2 is 10. 10 plus 7z equals 3. Subtract 10 from each side, get 7z equals negative 7. And then divide each side by 7, z equals negative 1. So now you know that x is 2, z is negative 1. We can go back up here into any of these three equations, substitute negative 1 in for z, 2 in for x, and solve for y. I'll take that first equation. It does not matter which equation you choose. I'm going to take that first equation, substitute negative 1 in for z, and 2 in for x. If you do that, you have 2 plus 2y plus 5 times negative 1 equals negative 1. Multiply 5 by negative 1, that is negative 5. Combine 2 and negative 5, that would be negative 3. So 2y minus 3 equals negative 1. Add 3 to both sides. End up with 2y equals 2. And then divide each side by 2, y equals 1. So now you know the value of all three variables. X is 2, y is 1, z is negative 1. Those represent the point of intersection of those three planes. So the coordinates of that point would be 2, 1, and negative 1. That is the point of intersection. And on this last system of equations, we have 2, 1, negative 1 as the point of intersection of those three planes. You may wonder, what do three planes look like intersecting at one point like that with coordinates of 2, 1, negative 1? This is what the image looks like. There you see three planes all intersecting at one point, and that point has coordinates of 2, 1, negative 1. X is 2, y is 1, z is negative 1. Remember, that is a three-dimensional appearance there. So it doesn't matter which axis is the x-axis, which axis is the y-axis, that's going to rotate around. It's like a basketball. If you label it with x, y, and z, and you throw the basketball, it's going to spin around. It's not going to end up the same. This could spin around. So some books may label this as x, some may label this as y, and some may label this one coming out at you as z. But it doesn't matter which axis is which. They're going to rotate anyway because it is three-dimensional. So that is an image of three planes intersecting at the point 2, 1, negative 1. We'll solve this system of three equations and three variables. First step is to choose two equations and eliminate one of the variables. It does not matter which two equations you choose, and it does not matter which variable you eliminate. So for this, I'm going to go with the first and second equations. First and second equations, when you're deciding on which variable to eliminate, the x looks pretty easy. You multiply the bottom by 5 to eliminate the x, or the z looks pretty easy. Multiply the bottom by 2 to eliminate the z. So for this, I'm going to multiply that bottom by 5. I am going to eliminate the x. So if you take the bottom by 5, and again, you do not have to do it this way. There are many, many ways to start this. It doesn't matter which two equations you choose, and it doesn't matter which variable you eliminate. So a lot of different possibilities you could start this with. So I'm going to multiply the bottom by 5. Top stays the same. If you take the bottom by 5, it would be negative 5x plus 15y minus 10z equals 0. And if you add those together, the x's will be eliminated. Negative 4y and 15y, that is going to be 11y. 4z and negative 10z, it's negative 6z, and 18 and 0 is 18. Circle that, mark it somehow, because you're going to use that in a little bit. Choose a different pair of equations then and eliminate the same variable so that you can put that new equation that you have down here with this equation and eliminate one of those variables. So I'm going to go with the second and third equations from up there this time, and I need to eliminate, again, the x. So to eliminate the x, multiply the top equation there by 4, end up with negative 4x plus 12y minus 8z equals 0. Bottom equation stays the same, 4x minus 2y plus 7z equals 3. So if you add those together, you can see the x's are eliminated. 12y, negative 2y, that makes 10y. And negative 8z and 7z, if you add those, that is negative z. Also on the end, 0 and 3 is 3. So 10y minus z equals 3. Circle that, mark it somehow. We're going to put these two together and eliminate one of the variables. So take those two new equations you just have and eliminate one of the variables. And it doesn't matter which variable you eliminate. The z looks pretty easy. The y, to eliminate that, looks a little bit more difficult. But to eliminate the z, I'm going to multiply the bottom by negative 6, so that turns into a positive 6z. Make sure you multiply each term on the bottom by negative 6. We end up with negative 60y plus 6z equals negative 18. So if you add those together, the z's will be eliminated. That's what you want to have happen so that you can solve for y. 11y, negative 60y, that is negative 49y. 18 and negative 18 is 0. Divide each side by negative 49, so y equals 0. Once you know the value of one of the variables, that's the key that's going to unlock the door to all the other variables. Now that you know y is 0, you can go back to one of these two equations and solve for z. So just pick one of those equations. It does not matter. I'll take that bottom one down there. 10y minus z equals 3. Substitute 0 in for y. So it'd be 10 times 0 minus z equals 3. Have negative z equals 3, and then z equals negative 3. So z is negative 3, y is 0. Now you know two of the three variables. You can find the third by going back to one of these. Anything up here is open game. When you're solving these equations, you can use anything at any time. So you can use any equation to substitute into. But now that I know z is negative 3 and y is 0, I can go back to one of these threes to find x. And it does not matter which equation you choose. For this, I'm going to go with the first one. 5x minus 4y plus 4z equals 18. I know that z is negative 3, substitute that in. And I know that y is 0, substitute that in. So it'll be 5x minus 4 times 0 plus 4 times negative 3 equals 18. Negative 4 times 0 will just be 0. 4 times negative 3, it's negative 12. So 5x minus 12 equals 18. Add 12 to both sides. You have 5x equals 30. And then x equals 6. So x equals 6. Y equals 0. Z is negative 3. The point of intersection of those three planes would be 6, 0, negative 3. We're going to find the point or points of intersection of these three planes. So I'm going to solve this system of three equations and three variables. First step is to choose two equations and eliminate one of the variables. So for this, I'm going to go with the first equation and the second equation. If you look at those two equations, the x looks pretty easy to eliminate because you could just multiply the top by 2. You'd have a negative 10x there and 10x. Also, the z looks easy to eliminate. Just multiply the top by negative 8. Then you'd have negative 8z and 8z. So a lot of different ways you can start this. For this, I am going to multiply the top by 2 and eliminate the x. So if you take the top by 2, make sure you multiply each term by 2, including what's after the equal sign. So take the top by 2, get negative 10x plus 6y plus 2z equals negative 30. Bottom equation then stays the same. If you add those together, the x's will be eliminated. 6y and 2y, it's 8y. 2z and 8z, that is 10z. And negative 30 and 18, that is negative 12. Circle that, mark it somehow, because you're going to be using that in a little bit. Next step, choose a different pair of equations and eliminate the same variable. So I need to eliminate, as I did the first time, the x. I'm going to go with the first equation and the third equation. First and third, so if I go with the first and third, I'm going to multiply the top equation by 3. That'll make that a negative 15x and a 15x. Those will be eliminated. So take the top by 3. Bottom will stay the same. Make sure you multiply each term on top by 3. Get negative 15x plus 9y plus 3z equals negative 45. And again, the bottom equation will stay the same as 15x plus 5y plus 7z equals 9. If you add those together, the x's will be eliminated. 9y and 5y, it's 14y. Also 3z and 7z is 10z. And negative 45 and 9, that is negative 36. Circle that, mark it somehow. Now we're going to use these two equations, put those together, and eliminate one of those variables. It does not matter which variable you eliminate. So put those two equations together. The z looks pretty easy to eliminate because all I have to do is multiply the top or bottom by negative 1, then make it a 10z and a negative 10z. And I am going to do that, multiply the top equation by negative 1. Make sure you multiply each term by negative 1. So it's negative 8y minus 10z equals 12. Bottom equation stays the same. Then I add those together. The z's will be eliminated. Negative 8y and 14y, that is 6y. 12 and negative 36, that is negative 24. Watch your signs. One little mistake, and you're going to mess the whole thing up. So be very careful, very tedious on what you're doing. 6y equals negative 24. Divide each side by 6, so y equals negative 4. Now that you know y is negative 4, you can go back into one of these two equations, substitute negative 4 for y, and then solve for z. It does not matter which equation you choose. My advice, stay away from big numbers, stay away from negatives. Those will cause some mistakes. I'm going to substitute negative 4 in for y into that first circled equation. So it's 8 times negative 4 plus 10z equals negative 12. 8 times negative 4, that is negative 32. Plus 10z equals negative 12. Add 32 to both sides. Have 10z equals 20, and then z equals 2. So now you know the value of two of the variables. You know that z is 2 and y is negative 4. So you can go back up here where we have all three variables, pick one of those equations, it doesn't matter which equation you choose, and substitute 2 in for z and negative 4 in for y. So I'm going to go with the second equation up there. 10x plus 2y plus 8z equals 18. Substitute 2 in for z and negative 4 in for y. So 10x plus 2 times negative 4 plus 8 times 2 equals 18. Multiply 2 by negative 4, it's negative 8. And multiply 8 by 2, that is 16. Combine the like terms, negative 8 and 16, that is 8. So 10x plus 8 equals 18. Subtract 8 from each side, get 10x equals 10. And then x equals 1. So x is 1, y is negative 4, z is 2. The point of intersection of those three planes has coordinates of 1, negative 4, and 2.